This video is on section 3.2. That's not what I wanted. Hold on, troubleshooting. All right, well, it looks like we are just not going to put this in presentation mode because for whatever reason, it's being weird. So let's just keep it as is. All right, so we talked about lots of data, classifying data, and in 3.1 we talked about putting qualitative data into a table and creating a frequency distribution. So we want to now talk about, after we've summarized the data and all that good jazz, now we want to put into displays, into some sort of graphs. And what graphs go with qualitative data? So let's explore. So a bar chart, which you most likely have seen quite often, is a simple graphical display in which the length of each bar corresponds to the number of observations in a category. The instruction. So things you need to be aware of. So you may have seen bar charts before, but what you may not have paid attention to is what are good qualities of a good bar chart and what can make a bar chart misleading or poor qualities. So bar charts are constructed horizontally or vertically, it doesn't matter. If the categories have some associated order, they maintain that order in the bar chart. So if we're talking about I don't know, maybe grades. So the categories are A, B, C, D, F. You would maintain that order in the bar chart. Even though it's not numerical, some categorical information can be ordered. Remember, there are two levels of measurement, nominal and ordinal. So the moment that we order it, it does jump up to the ordinal level of measurement. If okay, miscellaneous or other categories should be listed at the bottom of the chart if oriented horizontally, or far right if doing this vertically. The difference in bar length is the principal visual feature in comparing differences in category amounts. So the longer the bar, the taller the bar, we are going to have a higher frequency, and the shorter or smaller the bar, we're going to have a lower frequency. So bar widths should be chosen that are visually pleasant and should not vary in width. So you would never look at a bar chart and see a really fat bar and a really tiny skinny bar. That really just makes it difficult to look and compare the categories. The categories have no weights on them, so the bars should always be of equal width. Appropriate shading should be used when creating a bar chart. So there are definitely ways to make bar charts very difficult to read. So if you put a picture as a background, like a big picture of your face in the background, and you have bars coming up over your face, that's very distracting. People are going to be distracted from the data you are trying to display, and they're going to miss the message. So when you are doing graphs, again, typically this is a way of displaying your data, and you're displaying your data for someone, whether it be for yourself, a professor, or stakeholders of a company. So you want to make sure that you don't have anything distracting or misleading in your graph so that it doesn't detract from your presentation. The spacing between bars should also have an appropriate space and be equal distant between each bar, and make appropriate sense. This is categorical data, so there is no number line on the x-axis necessarily, so the spacing should be exactly equal and even. Grid lines extended into the body of the chart are often useful and may be included if deemed helpful. So for categorical data, it's not as critical that we have grid lines, but when we get into the section talking about quantitative data and bar charts, then it does make perfect sense to have some sort of grid so that you could see the number line better. If there is sufficient room on the graphs, labels should be provided for each bar and for each axis. So the three things that have to have labels, no questions asked. You have to have a title for a bar chart. You have to label your X and your Y axes. If they are not labeled, that is not good. That is the basic labeling. Now, what they're talking about is if we have enough room to label each bar, we could either label it right on the x-axis or use a legend and color the bars so that we can associate the color and the legend with what category it represents. Notes on sources of data or other footnotes should be given below the chart. So that's a very professional chart. If we are pulling data from a source on the internet, we would want to note where we got our data from. Okay, scales for the axes should be chosen that will most effectively allow for the desired comparison. So in some cases, the frequency would be used, which is the count of the data. In other cases, relative frequency makes more sense because the proportion is what should be compared, not the count. So for example, in a case where we are looking at the number of stolen cars in the countries, if we compare the number of stolen cars in each country by the count, that does not account for how large the country is. So the United States would be in the top three because we are one of the largest countries when it comes to density of population. But Australia might be really, really low in the count of stolen cars because Australia has a much lower population than the United States, or something like Finland, or they don't have as many people. So count actually is a misleading statistic to use for that type of comparison because the populations are not equivalent. You would want to use a proportion because the proportion of cars takes into account the number of stolen cars in the United States divided by the number of cars in the United States. So therefore, our proportion might be less than 1%, even though our count is the highest count of stolen cars. We might have the most cars out of all other countries. But proportion wise, only 1% of those are stolen versus Finland, maybe it comes out to 4% because the amount of stolen cars compared to the amount of cars there are in their little country is a much higher proportion. So you need to think about your data. And if you are comparing categories, especially categories that come from different populations, you need to think of which statistic makes the most sense. Should it be frequency, relative frequency, or percent? Percent and relative frequency are the same statistic in a sense. So typically I don't use percents for bar charts. I would use them for pie charts, which we'll get to in a moment. So here are some examples of misleading, what's misleading, what's not. So one of the factors you want to pay attention to, and again, when we look at a graph on the internet and we're just scrolling through, we typically just take a snapshot of what we see and we believe what we see. We don't really look for, is this graph drawn appropriately? So for example, if you look at the one on the right, these are the same graph, but this one starts at 180 and this one starts properly at 0. Notice that when we start at 0, we give a full scale on this vertical axis, the differences between the bars are minimal. But if we zoom in to the very top of the bar, literally we are 180 is right about here. So we are cutting off the top and zooming into the top of the bars. It makes these gaps look so much more dramatic than what they really are. If you look at the scale, this is only a count of $15,000 difference, which really in the grand scheme of things is not a lot when you're talking about $200,000. So if this was the snapshot you got, you would say, oh, Beth, you're doing great. She's doing way better than Susan. Susan's not making a lot. But really, it's only a difference between about $208,000 and Susan's making 188. Okay, so I mean, they're right in the same range for salaries, but this graph makes it look like Susan's poor and Beth is rich. But if you look at this bar graph, this is properly done because you can see that all four are producing the same total sales in a general area. A Pareto chart is a bar graph. It's a type of bar graph, but it has the order based on the frequency. So if you wanted to have the highest frequency to the lowest frequency, remember they're categorical, so there is no real order on where you put the categories. But in a Pareto chart, you would order them based on their outcomes, their counts. So here you see, again, we're starting at 0, so this is a good graph. The highest count to the lowest count, and that's what defines a Pareto graph. Now, there are a bunch of different versions of bar charts. For example, there's something called a stacked bar chart. Some cases, stacked bar charts are appropriate to use, and in other cases, they make it very difficult for readers to read the information. So you see here that this chart is talking about Winter Olympic medal count, how many gold, silver, and bronze in the particular country, but you have to really pay attention. There aren't 33 bronze because the bar goes all the way up to 33. It's only this dark part. So you have to guesstimate that this is about 24 to 34, so maybe 10 bronze medals. You have to really take a look at the space it's taking up on the count. So the only one that's straightforward is this golden bar. This comes up to like, I don't know, 13, but then you have to count in here, and that's how you would read these. We're going to practice more on graph reading in one of the future sections of chapter 3. A pie chart is a circle graph. Okay, so this is typically used to display categorical data, and you normally use the percentages because when we think of the pie slices, think of a pizza. Okay, if you have a really big pizza, you know it's taking up a larger percent of the total circle, and if you have a skinny piece of pizza, you know it's taking up the smaller percent of the total pizza. So the circle represents the total pie available, and the slices are proportional to the amount in each category. One of the advantages of a pie chart is the ability to easily compare the total in each of the classifications to the total number of observations. So we take a look at this pie chart. It is very, very easy to see that Brianna has the biggest slice of the pie for whatever this is talking about. Oh, percentage of sales. We're back to percentage of sales. Brianna clearly has sold the most, and Katie is her runner-up. We don't even have any numbers on this pie chart, but visually we can see the bigger the slice, the more they take in. Although the pie chart are useful displays of categorical data, they have their limitations. Once the number of categories rises above 10, the information conveyed by the pie chart is much less meaningful. It is very difficult to read a pie chart once your categories get too big. So taking a look at here, we have 5 categories, very clear pie chart. Here we have 40 employees. It's almost impossible to really look at this unless there was one that was really extremely fat. But when they're all kind of little tiny slices here, especially without labels of percentages, that does not make it very easy to read, and we would want to switch to a bar chart at that point. Now, this is going to be our first time taking a look at our Guru and how to produce bar and pie charts in our Guru. So let me stop this and let's switch over to our Guru screen. And hopefully you have all created your accounts so that we are not working with issues of creating accounts. I did warn you this day was coming. Let's sign into our Guru. Okay, so now I'm in here. Let me orient you a little bit about this interface. So this is web-based. There was nothing to download. You have a bunch of help videos here by category. You also have a PDF of a help with a clickable menu here. You also have help videos within each thing you're trying to do inside of our Guru. So we are going to be using data in a couple different ways. In some future chapters, the data set will already be here because the data that corresponds to our book is already preloaded. It's one of the reasons why I kind of liked the Hawks book. So I went over here to data, and I'll show you import data. If I went to the data set repository, I would look for my Hawks book. There's a lot of data sets that are already preloaded in here. Hawks. So every data set that we run into is already in here. I don't have to upload it. I just have to click on it. Let's say that I'm working on a problem and it tells me to use the Bill Length data set. I'll just say import and it automatically adds it to my data list. Now, for today, I don't have any pre-done data in Excel file. I won't be importing it. I'm actually just going to build the table real quick. And I'm going to show you how to do that. So let's say that we did a surveying class. This is something I would typically do if we were on and doing a surveying class. I would ask everybody what their pets are. So I've come up with some fake data, pretending I did the survey. Um, I didn't keep any of my former classes' data. So I would come over here to data. So let me start from the beginning. We come over here to data. We click data import, but we're going to create a new data set, not a new table, data set. There is a difference between the two. And for the purposes of this course, we don't need to know about the table. That's going to be in stats 2. Now, I am just going to do a quick table where this first variable is going to be called pets. And I am going to type my categories. So let's say that people had dogs. And in order to add another row, I'm using this add a single row button. And let's say I'm going to have 5 categories. So let me get 5 in here. I double click and I'm going to put cats. Hitting enter locks it in. I think if we hit the down arrow, we will be able to go down to the next cell. Yes, down arrow works better. Down arrow and goats. Okay. And then I am going to now need another column. I need a frequency column. So I'm going to press my add a single column. Bloop. I'm going to label this frequency or count, but frequency is the statistical translation of count. Let's say 10 people I surveyed said they had dogs, 34 said they had cats, 12 said they had pigs, 1 said they had bird for a pet, and 6 people have goats. So I live up in the northwest corner of Connecticut, so pigs and goats are very common up here. Okay, we're going to want to save this data. So I'm going to save this as a pet survey. I'll just save it as pets, and I'm going to click Save As. So now we see that we have, if we scroll to the bottom, which for you guys, you shouldn't have anything in here. I have a ton of stuff. I've already done this before. So now this is saved as pets. And the first thing you always want to do when you upload a new data set or you create a new data set is you're going to want to double click it in your data list to make sure that it imported correctly. So you're always looking to make sure that the first line is your labels and that all the data you needed actually are in these little cells here. Okay, you want to make sure there are no other labels that made it down into the data cells because that's going to screw up your graphs or your analysis in the future. You also want to make sure that you have labels up here and that your data isn't up in the labels because our guru thought that they were labels on your data. Okay, so now that we have our data imported, we are going to head over to plots. First thing we will do is we will create a bar chart. And when you save these in our guru, this is where they show up. So I've saved one before. So if you ever save one, you are going to find it listed here in plots you've already created, and I'll show you that. Let's create our first bar plot. Now, if I forgot how to fill this out, here is the little help video right embedded inside of the command of a bar plot. So that's what I'm saying. It's very easy if you forget. You just watch this, and they're usually very small and easy to follow videos. You can do categorical data or numerical data. We'll work with the numerical data in a future video for one of the future sections we're going to be covering. So right now I want to select my data set, pets. And then I'm going to make sure I'm in the categorical tab because this is categorical data. Okay, the first factor is pets. That is going to be my x-axis. It wants to know, do you want your bars to be side by side or do you want them to be stacked? And we don't want stacked, we want side by side. We want the counts to be used. So this would be frequency, or do you want it to be proportions? It will automatically calculate proportions for you. We'll keep it at counts for this one. Frequency, we labeled that column frequency, so that helps. We can add value labels if we want. Let's see what that looks like. And remember, there's 3 things that always need to be labeled. The title, which we'll call this pet survey. the x-axis, which are the pets, and the y-axis, which is the frequency. Okay, I'm going to hit the eyeball when I'm all done. And I have a pretty bar chart. Now, if I forgot anything, or if let's say I didn't really like the labels, you can always go back to basic and change that. So I can take off the labels, re-hit the eyeball, and it will make that change. So if you hit it and you forgot to put the title in, just go back to basic, add it, and hit the eyeball again. So now over here, if I wanted to save this as pet survey bar chart, I can save it right inside of our guru. So now you see it popped up over here and I can access it later if I was doing it for a project or a homework. Or if I wanted to submit this was assignment that I needed to do for class, then I can always hit my Word document button and it will download it as a Word doc. Now it does, it has a weird download. It gives you a Word doc, which is usually the data. It gives you a picture, a PNG file, which is the graph, or an HTML link, which will link you right to everything. So just make sure if you're uploading this at any point in time in Blackboard that you select the right files or give me all of them. Okay, so that is our bar chart. Now let's create a pie chart. So we're going to go back to create plot. And I'm going to go to pie chart. I don't need to clear this out because notice everything I'm doing is creating a new tab. So let's go to pie chart. Okay. Again, if you needed help, you would select this video and watch it, and it'll walk you through all these different window panes. So let's select our data set first. Factors, pets, the frequency, we labeled frequency. Okay, we don't need to plot by group. We're gonna leave that out. You don't need this part. Now, do you want the values to be on your pie chart? So we have a choice to not have it labeled or to put the count or the percent. Now for pie charts, I definitely prefer percents. And this little box is saying, do you want the percents labeled inside of the slice or have it removed and have it outside the slice? I'll leave it inside for now. And if I think it's too cluttered, remember, I can always go back and uncheck that. Radial for the labels of the slices means that it's going to label in a circle. So I'll leave it so you can see it. I don't like radial, I like horizontal, but I want to show you what it looks like. And again, I have a choice of having the labels inside or outside. Now I probably shouldn't have the percents and the labels both inside, but again, I'll show you so that I can also show you how to make adjustments when you realize you don't like something. Okay, we can show the legend and a title, pet survey. All right, eyeball. So you can see the radial labels of the slice go around in a circle. I find that very difficult to read. You can do a legend instead, which is usually better. So let's go back to basic and let's say, you know what, I really don't need the labels. Actually, I like the percents. The percents are fine, but let's do it horizontal. And let's not have the labels inside. Let's see what that looks like. Well, that's not pleasant. I don't know why they wouldn't put the categories inside the darn slices, but I guess we really don't need the slices if we have this legend here. So let me change this up. Let's say that I want to show the legend with the colors so that I don't have to have the label slices. So the names of the categories are going to be in the legend, but I don't want the percents part of the legend. I want the percents to be inside the circle. Let's see what that looks like. Ah, I think I like that better, even though I would prefer that they use a different font because you can't see the blue on blue. So maybe I should put the percents outside, but you see how you have many options to clean it the way that you want. And again, I can save this as pets pie chart and save it right inside of our guru, or I can download it as a Word document and upload it into Blackboard if it was an assignment. Okay, this concludes our little lesson on 3.2 qualitative graphs.